video talks about quantum computation. Before you guys roll your eyes at me, let's play a game, a coined game. At the very beginning, we initialize a coin as a tail. I play with a coin first. I could flip it or do nothing. I write down my choice on a piece of paper but keep that from you. Then, you play with a coin. Similarly, you make your own choice without revealing that to me. Lastly, I decide if I want to flip it or not. After these 3 rounds, we look at the coin. If it's a tail, I win, but if it's a head, you win. So, what's the probability that you win the game? We could list all the outcomes and calculate. As you can see, both of us have a 15% chance to win. However, what if I was not a human? I was a quantum computer instead. What would be the odds that you win? Someone actually did such an experiment, and you could repeat the same experiment yourself. IBM launched the IBM Quantum Experience in 2016. It's a free platform where you can play with the real quantum computers. You just need to sign up, get an account, and try that out. I'll put the link below. Anyway, the results from a real quantum computer showed that if you played against a quantum device, it was likely that the quantum computer would always win. This is a result from over 8,000 repeated games, and it lost only due to the operational errors. Why is that? Did the quantum computer cheat? Of course not. Actually, this comes from the nature of quantum physics. For a classical coin, it could be either a head or a tail at one time. In contrast, a quantum coin could be in a superposition, a combination of head or tail, with some probability of being a head and some probability of being a tail. So, in the first round, when I play with my quantum coin, I could apply a Hadamard gate so that I get a quantum coin in this kind of state. A Hadamard gate is an operation that maps a tail into a superposition of head and tail. If a Hadamard gate is applied to a head, we got this. Of course, probability can't be negative. These numbers are amplitudes, not probabilities. The probabilities are the square of the amplitudes. It is uncertain if it's a head or tail before we look at that coin. In our coin game, we don't reveal the coin before the end of the 3rd round, remember? So the uncertainty remains during the whole game. In the 2nd round, because this quantum coin is in such a combination of 15% head and 15% tail, it remains in this superposition, whether you flip it or not. In the 3rd round, I applied another Hadamard gate to this quantum coin. If we do the math or write down all the possible cases, I would get a tail with a 100% chance. And this is quantum computing. A quantum coin may be counterintuitive to you, but in fact, the fundamental particles like electrons and photons do behave this way. The fact that this world is essentially uncertain is certainly intriguing. So, muggles, welcome to our magical quantum world.